discrete probability distribution has a random variable which has the definition of that it is a, a real valued function whose domain is the sample space of the random experiment. So it can be summarized here as and the random variable will be discrete. It will be discrete RV if it contains the values such as x1, x2 to xn, which are discrete in itself, means not continuous numbers like real number between 1 and 2. So such a random variable is called a discrete random variable. While a discrete probability distribution, discrete PD, is one such that the random variable x has values only x1, x2 to xn, and having probabilities say p1, p2 to pn. So such an experiment all in all becomes a discrete probability distribution. One important characteristic of the probability distribution is that sum of all those probabilities must be equals to 1, and each of the probability must lie between 0 and 1 only. So because probability cannot be negative nor it can be more than 1. Usually, a discrete probability distribution is represented as the random variable x with the probability correspondingly in such a manner that x1 has probability p1, x2 has probability p2, and if there are n such random variables, then n such probabilities. Each of the probabilities uh, positive and lying between 0 and 1, such that the sum of the probabilities is 1. Now the another thing is the expectation or the mean of random variable. Expectation of probability distribution, and the expectation is also known as the mean. So mu, which is mean, or the expectation ex, is actually sum of the product of the random variable with the corresponding probability. So all in all, you can say that it should be equals to x1 p1 plus x2 p2 and until xn pn. So this is the expectation or mean of the probability distribution. Now the variance of the probability distribution of a discrete probability distribution, practically variance has symbol sigma square. So sigma square of x is sum of xi minus mu square with the corresponding probability, and it can be easily verified that this is equals to the sum of the product of xi square with the probability pi minus the summation of xi pi's square, or it can also be written as xi square times pi sum minus mean square, because this part is actually equals to the mean of the PD. Now let's discuss a few examples. So we have to check if followings are valid PD probability distribution. We have to check that. So first of all, there is a random variable and corresponding probability. Let's say the random variables are -1, 0 and 1, while the probabilities are 1 by 4, 1 by 2 and 1 by 3. So probabilities are positive. So we have to check whether the sum is equals to 1 or different from that. So sum of all the probabilities, that is 1 by 4, 1 by 2 and 1 by 3, comes out to be, it has the LCM of 12, so it should be 3 plus 6 plus 4, and the numerator becomes 13 and denominator is 12, which is greater than 1, so not a valid PD. Now suppose the random variable is assumes values 0, 1, 2 and 3, while the probability distribution assumes values like 0.1, 0.4, 0.3 and 0.2. Now find the sum of all the probabilities. 0.1 plus 0.4 plus 0.3 plus 0.2. So because it is 1, so it is a valid PD. And none of the probabilities should be negative. If either of the probability come out to be negative, then it cannot be a valid PD. Because question in the part 2 is a PD, is a valid PD. So let's note it down once again. The random variables for 0, 1, 2 and 3, while the probabilities were respectively 0.1, 0.4, 0.3, 0.2, 0.1, 0.4, 0.3 and 0.2. If you want to find the mean and the variance, so first of all I need the product of x and p. So it is 0, 0, 0.4, 0.6 and again 0.6. This sum will give me the mean. This sum comes out to be 1.6. So mean of this PD is 1.6, which is sigma of the corresponding probabilities with the random variable. Sum of corresponding probability and the random variable. Now if I want to find the variance, so let's find x square p first. So if multiply xp with x once again, it will be square of x times p. So it is 0, 0.4, 1.2 and 1.8. Let's find this sum. This sum is 3.4. So variance of this PD, as we discussed, the formula is sum of x square p minus the square of mean. So it should be 3.4 minus square of 1.6. So it should be 3.4 minus 2.56, or the answer should be 0.84. This is variance. If SD needs to be calculated, it should be the square root of, because it is sigma, so square root of 0.84. Okay. Let's have another example. Now the question is, there is a PD given a probability distribution with random variable and probabilities respectively as 1, 2, 3, 4, 5, and the values of P are k, 2 twice of k, once again k, then k over 2 and 3k. So find k. This is the problem. So we know that the sum of probabilities comes out to be 1. So it means that the sum of k plus 2k plus k plus k by 2 and 3k, it must be equal to 1. We find this sum is 7.5k, which is 1, or it can be 15 over 2k, which is 1. So the value of k should be 2 over 15. Now some more can be added to the same problem, that we may be asked to find the mean and the variance, which is now a trivial case. We can easily find applying the given formula.